Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using 9. In this chapter we're going to explore independent random variables. When an analysis involves pairs of random variables, it's often very useful to know whether or not the random variables are independent of one another. This chapter is going to explain how to assess the independence of random variables. In order for two random variables, x and y, to be independent, they have to satisfy the following conditions. These two conditions are equivalent. If either one is true, the other is met by definition. But the first condition would read as the probability of y given x is equal to the probability of x for all values of x and y. And the probability of the intersection of x and y is equal to the probability of x times the probability of y. In other words, either one is likely to occur. That's what it all boils down to. So let's take a look at a test here. We've got a table here in the upper left-hand corner, and we're looking at the probabilities of x being equal to a specific value and y being equal to a specific values. And we're looking at the totals. So you can see the totals running down and the totals running across for the probabilities. So let's use the first example. The probability of x, given that y has occurred, is equal to the probability of x. Well, the probability that x equals 1 is equal to 0.4. And you can see that from the total line. Now, the probability that x equals 1 given that y is equal to 3 is 0.1 divided by 0.25, which is equal to 0.4. And the probability that x equals 1 if y equals 4 is 0.3 divided by 0.75, which is also equal to 0.4. So it clearly works where x equals 1. Let's try it with x equals 2. X equals 2 is 0.06. The probability of x equals 2 if y equals 3 is 0.15 divided by 0.25, which is 0.6. And probability x equals 2 where y equals 4 is 0.45 divided by 0.75, and that's equal to also 0.6. Therefore, x and y are independent. It's a simple test that we can execute. All right, let's look at another example of another table, and this time let's use the second test, that the probability of the intersection of A or B, which is equal to the probability of A times B. And let's see if that test proves these values to be independent or not. And this is a different table. So, to begin with, we can look at and say the probability of A equals 1 intersection with the probability of B equals 3 is equal to 0.1, just by looking up in the table. Well, the probability of A, we can see, is 0.4, and the probability of B is 0.3. So, using our formula, if we just insert the values, 0.01 is not equal to 0.4 times 0.3. It's equal to 1.2. Therefore, x and y are not independent. That completes this chapter of the class. Feel free to move on to the next chapter.